Hello guys, this is Dr. Possibility from Excel Academy, and in today's class I'm just going to explain vectors and scalar quantities, of which I'm just going to solve some few questions from one of the tutorial sheets at one of the universities in Zambia. So please make sure that you follow up. Okay, so the first question is saying simply saying the given vector component corresponds to the vector r as shown. Okay, so the first question is saying use the inverse tangent function to find the angle. Use the inverse function to find the angle. So if you look at a vector, so a vector, for example, let's say this is my Cartesian plane, which I've already drawn there. So let's say I have this vector. Okay, so if this is my vector component, so this is a vector which I'm looking for. Okay, so if this is a vector r, so you're going to discover that this vector is having two components. It's having the y component and the x component. So this guy in the x-axis is the x component of that vector. Okay, so this is normally said to be Rx. And then when I move from here, I go up there, you're going to find that I'm now going to have the y component, because the y component has to be parallel with the y-axis, and then the x component has to be parallel with the x-axis. So in this case, if you look at this guy, you're going to discover that this y component is just ry. Okay, so the y component of that guy. Now if you look at this again from the vector point of view, you're going to discover that when this component and that component move, they normally make this angle there. So this angle, we normally call it as the theta. Okay, so when you talk of a vector which is moving at a given direction or at a certain angle, remember in physics, the word direction is just telling you the angle. Okay, so when they ask you find the direction, they simply mean to find the angle. Okay, so in this case, when you are asked to find the direction, they are just simply telling you to find what? To find the angle, which is this angle. So normally when you are asked to find the angle, it's very easy to do. Okay, it's very easy to do. So what you are supposed to do, all you need to do is to say to find that guy, which is the angle, you just say tan theta is equal to the absolute value of ry, okay, over rx. Okay, like that. All right, so the absolute value. So there are cases whereby y is the negative part and the y is negative, or maybe x is negative. So to find the angle, which is theta, you just simply say tan theta is equal to the vector component in y-axis over the vector component in x-axis. Now when you also need to look at, let's say, the magnitude. Okay, so when you talk of the word magnitude, the word magnitude just simply means the length. It can be the length or size. So when you say magnitude, when they ask you to find the magnitude, they're just simply saying find the size. Okay, so this size can be the length, it can be the length, it can be the force, depending on whatever you have been given. So this is the reason why we say a vector always has the magnitude and what? And direction. All right. So how can you find the magnitude of a vector like this one? So for you to find the magnitude of a vector like this one, you need to understand one thing. You need to understand that this is more like the hypotenuse, then this one is the opposite. Why is it the opposite? Because it's opposite with the what? Is opposite with the angle. And then this one is normally the what? The adjacent. So in easy term, we can say r squared is equal to square root. You take the what? You take the x component squared plus the y component squared. Okay, so this square root is coming from the fact that we are going to introduce a square root, that's so that to get rid of that squared. So this guy and that guy, they'll go, and we are going to have that guy there. So in this case, to find the magnitude, which can be the length, it can be the height, it can be anything, we just simply say r squared is simply equal to square root rx squared plus ry squared. Okay, so what method is this? So this method is just known as the Pythagorean theorem. So I'll just say P theorem. Okay, theorem, to avoid wasting time. So that's the Pythagoras theorem. All right, now let's quickly go back to our question and check out what we have been given as the vector components. Okay, so guys, if you look at how the drawing is, you're going to find that this is your rx, this is your rx, and that is your ry. Okay, so in this case, you're going to find that rx, which is that, is just simply equal to what? 14 meters. Okay, and then ry, which is the r component, is just equal to what? Negative 9.5 meters. And then we have been asked use the inverse tangent function. Okay, inverse tangent function to find the what? The angle, which is the direction, So let me quickly go down and solve this question. Okay, so in this case, we are now looking for the the angle, which is just the direction. So for us to find the direction, what are we going to do? So let's say the way it is, this is your Cartesian plane. This is your Cartesian plane, this is your x component, this is your y component. And then the real angle is coming from the real vector is coming from the origin there, and then you are also having the x component and the y component. So the x component, it is this one, which is 14 meters. So this one is 14 meters, and it's going like that. And then y component, it is this one, which is simply negative 9.5 meters. Why is it negative 9.9 meters? It's because the y-axis is negative down there, but the x-axis has been maintained to be positive. So to look for the angle, we're just simply going to say tan theta is simply equal to the absolute value of the y component over the x component. Okay, so this is just simply means tan theta is simply equal to negative 9.5 over 14. Okay, so these are the absolute value. So we are just simply having tan theta is simply equal to 0.67857 9.57. Okay, so from here, if you work out that, you're going to have tan theta is equal to tan inverse of what we have found there, which is simply 0.67857. Okay, so if we have that, what are we having now? What are we simply having? So our theta is just simply equal to 34 degrees. Our theta will just simply be equal to 34 degrees. Okay, so this is our theta, which we have simply found. Okay, so what else have we been asked? What else have we been asked? Okay, let me quickly go back up. Let me quickly go back up. Okay, so the other question is saying use the Pythagorean theorem to determine the magnitude of r. So for us to find the magnitude of r, what are we going to do? By the way, if you look at theta here, you find that tan is negative in this guy. So tan is negative in this guy, so you can put a negative there. So because tan is normally negative in the fourth quadrant, so you can put a negative there, and that will be your solution. Or if you want, you can just plug in a negative as you were solving. Okay, so take note of the fourth quadrant, the theta has to be negative. All right, so let's talk of the magnitude. So when you talk of the magnitude, this is our vector once again, and this vector, it is moving like it is. So there, this is our vector, and then it is having the two components. It is having the two components, which is the x component, which is this one, and also the y component, which is that one. Okay, so this can be our hypotenuse, this can be our adjacent, and this can be our opposite. Okay, so if we have that, we can easily work out the magnitude using what? The Pythagorean theorem. So we can just simply say r is equal to square root the x component squared plus the y component squared. So from here we can say r is simply equal to the x component, which is 14 squared, plus the y component, which is negative 9.5 squared. Okay, all right, like that. So if you work it out from there, if you work it out, you press using your calculator, what are you simply having? So what you are simply going to have is something like r is simply equal to 16.91 something. So this will give us 16.9187 2432. So when you round it off to two significant figures, because these values we have, they are in two significant figures, so you need to round it off to two significant figures according to the rules. So when you round it off, it's just going to be 17 meters. Remember the units which have been used. All right, so that's it for B. Let's go on C. Let's check out the third part. Okay, so what is the third part saying? The third part is saying show that the direction will remain the same. So show that the direction will remain the same, but the magnitude, which is the size, will double if r and x are double. So if r and x are double, so what they are simply saying is that what will happen if we double this direction, whereby when we multiply it by 2, it will surely give us what? 28 there. Then when we double this one, what are we going to have? If we double this one, it's going to be negative what? 19. So we have been asked what will happen if we were to double the sizes. Okay. So we'll use the same method. We'll use the same method to work out this part. We'll use the same method to work out this part. So I'll start with the angle. So we have doubled. Remember, this time around, Rx is equal to 28 and Ry is equal to 19 because we have doubled. So if we are looking for the magnitude, we can simply say the same thing. Tan theta is equal to the absolute value of the y component, which is negative 19, over the x component, which is 28. Okay, so from there we can say tan theta is simply equal to that guy, which is just 19 over 28. So tan theta inverse, you are going to find that your answer is 34. So your answer is simply 34. But because 34 is negative in the fourth quadrant, we can put a negative there. So if you look at the direction, which is the angle, it has not changed. It is still negative 34. Now, what about the magnitude? Okay, the magnitude, which is simply the size. So the size will simply say r is equal to square root the x component squared plus the y component squared. So r is simply equal to the square root of 28 squared plus negative 19 squared. Okay, so that's what we have. So what is r? R will simply be equal to when you work out that guy, what are you having? Okay, so what you are going to find that when you work it out, it's going to be double what we found here, which is 17. So when we work it out, we are going to simply have something like this. Let me just go back. Okay, so we are just going to simply have 34 meters. Okay, so if you look at 34 meters, this is what we have found. If you look at 34 meters, so 34 meters is double 17 meters. Okay, please, if my English is bad there, please you can write the right correct English. So if you compare this, you'll find that the magnitude has doubled, but the angle has remained the same. Okay, so I hope you guys have understood. Please subscribe to this channel because I'll be dropping medical related courses, for example, anatomy, embryology, biochemistry, physiology, and more other courses which those who will be doing medicine and surgery will be doing, and also other programs like mathematics for engineering students. Okay, so make sure that you subscribe to our channel, and you also make sure that you click on the notification button. Okay, so let me quickly go on this guy. So the vector involved in this problem are shown below. Set the length of a plus b equal to 37 units. Okay, all right, so what are we going to say? So what we have been told is that a plus b, vector a plus b is equal to what? 37 units. Okay, so vector a is equal to 37 units, and then we have been asked to find this vector here, which is vector b. Okay, so when we talk of finding vector b, we have just simply been told to find the magnitude. We have just simply been told to find the magnitude. Okay, so the magnitude is simply means that we are looking for the length. Okay, we are just simply looking for the length of vector b. So let me quickly work it out. The way you are supposed to work it out. Okay, all right, please subscribe to our YouTube channel. We have a lot of things to offer on this channel. Okay, so let me just rewrite some components. So we have this guy, which is 30, then we have this vector here, which is a plus b, and we also have vector a, which is simply negative 22a. All right, okay, so let me quickly work it out. So what we have been told is that vector a plus b is simply equal to 37, okay, units. Okay, and then like I said, we normally know that the length is equal to what? The magnitude. Okay, the length is equal to the magnitude. So how are we going to solve? So we know that magnitude, which is just the size, is simply equal to square root of x squared plus y squared, meaning the x component, this is the x component and that is the y component squared. Okay, so from there we can simply say that we have been given the magnitude of vector a and b to be equal to 37 degrees, 37 units. So we can treat 37 to be the magnitude. We can treat 37 to be the magnitude of both vector a and b. Okay, for both vector a and b. Why are we treating it as the magnitude? Because look at the diagram. So this diagram is like this. So you have been given this component this side, which is the vector a. Okay, and then you have also been given another guy. You have not been given this guy, which is vector b. So vector b, it is this side. Okay, so if you look at these two guys, they are forming a vector in between them. Which is this vector. Okay, so if you look very properly, you are going to understand that vector b is the y component. Vector b is the y component if you look properly, and then vector a is what? The x component. Vector a is the x component, because if I was to take this guy and plug it in there, they are forming vector a plus b. So if you were to take this guy and you illustrate it from there, you find that it's having the same magnitude. You get that? And then this vector a and b, this resultant, it is equal to what? 37. And then this guy you have been given, it is equal to what? It is equal to negative 22. So from there you can say 37 is equal to square root, this is the x component, so it's going to be negative 22 squared plus what? Plus b squared. Okay, plus b squared. Okay, so from here, when you work it out, you're going to find that you're going to have negative 22 squared plus b squared is equal to 37 squared. So where has the 37 squared come from? So you find that I have introduced a squared here to get rid of that square root inside. I've also introduced the square there. So this guy and that guy, they'll go. Then you're going to remain this with that side and also that like that. So from here, when you make this b the subject of the formula, you're going to find that it's going to be b is equal to square root 37 squared minus squared, yeah, minus negative 22 square. So that's what you are going to have when you make b subject of the formula. So when you work it out there, from there, you're going to simply have something like b is equal to, when you work, you say 37 squared minus negative 22 squared. Okay, you're going to have 29.748 94956. Okay, so from here you round off to two significant figures. So you're going to find that it's going to be simply 30 units. Okay, because we have not been given. So vector b is just 30 units. So the concept is just on you analyzing that vector. For you to have vector a and b, there was an issue of adding its components. For you to have vector a and b, which is this guy, vector a plus b, which is 37 units. This vector a and b is just the resultant, and this one and that one, they're just the vector components. So this is how easy the question was. So guys, in the meantime, I'll end here, and all I'm asking for is for you guys to subscribe to this YouTube channel. And for those who are interested in getting in touch with me for any form of help, please make sure that you WhatsApp me on this line. So this is the current line I'm using on WhatsApp. The other one, I'm using it but not often. Yeah, so in the meantime guys, this was Dr. Possibility from Excel Academy. Thank you for following up, and please subscribe to our YouTube channel. Thank you.